Hello, everyone. Thank you for tuning in to the EnerSys Product Learning Series. I'm Greg Laughlin, Product Marketing Manager in Broadband for EnerSys, and today we'll be covering the AlphaCell FT and FTX batteries. I'm joined today by two of our subject matter experts for our AlphaCell batteries. We have Eric Hill, who's Energy Storage and Systems Manager, and he's also joined by Grant Grunwald, Technical Marketing Manager. Thank you both for taking the time to join and share your knowledge with us.
Yeah, thanks, Greg.
Thanks. All right, Eric, let's get started with you. Can you tell us a little bit about this AlphaCell FT, FTX batteries?
Yeah, this is actually really cool, Greg. So this is the first time that on the AlphaCell product family, we've had a complete line of AlphaCell products designed specifically for inside plant. An AlphaCell FT is a thin plate pure lead TPPL, which we'll get into a little bit more, battery front terminal design meant for long duration float service backup. And then you have the AlphaCell FTX, which is also a front terminal TPPL battery, but it also is designed specifically for high temperature operation, 35C to 45C life, which we'll get into more detail later about why there are so many benefits of that.
All right. So what makes this battery so special?
So this battery, again, utilizes that TPPL technology, which again, we'll get into, which allows the battery to last longer, cutting operating costs and reduce the spending, recharge faster, which prevents downtime, deliver the superior energy density, which gives higher energy and higher power, and also while being non-spillable and fully recyclable. So reducing the number of batteries being disposed and minimizing the environmental impact.
Wow, a lot of good benefits there. Well, let's get a little bit deeper into this. Grant, can you explain a little bit about this TPPL?
Sure, be happy to. So TPPL stands for thin plate pure lead. The origins of this technology go back to the early 70s with the original VRLA patent. And it's been improving and advancing ever since then. The thin plate pure lead grids and active material are both manufactured with 99.9% pure lead. The grids are about 1 millimeter thick versus traditional lead calcium plates where the thickness is more in the range of 5 to 7 millimeters thick.
Wow, that's a big difference.
Yeah, that extra thickness is required to achieve similar life as that thin plate pure lead.
Oh wow, sounds like a big change. Tell me a little bit about the purity of lead. Why is that so important?
Well, the purity of the lead has an impact on many different things, but it's not just the purity of the lead, it's the purity of all the materials that go into the battery. And the big factor associated with that is minimizing the chemical reactions that are occurring inside of the battery. Minimizing chemical reactions translates into minimizing the corrosion rate, and that leads to a longer service life with that lower corrosion rate. So the batteries manufactured with lead calcium have to have thicker grids to accommodate for those additional reactions and that additional corrosion that occurs. But with that purity of the lead and all the other materials, the corrosion rate is much slower. So the grids don't have to be nearly as thick to last as long.
Oh, okay. All right. Yeah. So why are the thin a little bit? Can you explain it one more time?
So the grids are manufactured very thin. And it's proprietary technology that allows us to do that. Those thin plates allow a lot of power to be packed inside of the battery, and it also assists with cold temperature performance. Delivering capacity at those real low temperatures is a challenge.
Sure.
And that that thin plate technology assists with that, because we have a lot of surface area of the active material connecting to that thin grid. And then because of its purity levels, it's got very low resistance. So it provides very good low temperature performance.
Okay. Curious on that with the thin plate. I mean, it sounds like perfect sense. And, you know, I'm curious, like, well, why are we, you know, if this is technology that started in the 70s, why are we just now seeing the thin plates emerge? Is it a manufacturing? Is there something to it that makes it really difficult?
So it's actually not just now emerging. It's becoming more and more popular, specifically in the broadband market. We've had it in the broadband market for over 10 years now, and it's been wildly successful. So as I mentioned, this technology has been around since actually the early 70s, and it's well adapted and adopted by the marketplace in numerous applications. And it has been improving ever since it was first created. So the manufacturing technology is very unique. It's very difficult because it is pure lead, which is a very ductile material. Lead calcium, and we manufacture lead calcium products too. Lead calcium products, the calcium is actually added as a grain refiner. And that does several things. One of the things that it does is it makes the plate very stiff, very hard and firm. And that allows for easier manufacturing. You can move those plates around very fast, and you don't have to handle them as gingerly as you do that ductile soft lead. So the manufacturing processes that we've been developing since the early 70s have really created this special finesse for managing the pure lead that's ductile and a little bit harder to work with. And that's what makes the technology much more difficult to manufacture. But we've pretty well got that mastered now.
Yeah, and it seems like the benefits you get from it definitely are well worth it. So where are these batteries, these new FTX batteries, where are they being manufactured and built right now?
So EnerSys is a global manufacturer, and we manufacture the thin plate pure lead technology in 4 different plants across the U.S., 2 in Missouri and 1 in the UK in Newport, Wales, and 1 in Arras, France. But this specific battery, specific to your question, is manufactured in one of our Missouri plants in Springfield, Missouri.
Oh, great, great. Well, thank you. I'm going to turn our attention back over to Eric for a couple minutes. Eric, you say that the FTX uses proprietary design to operate at high temperatures. What does that mean?
So the old rule of thumb, right, with any lead acid battery is heat is #1 killer of batteries in any environment. So, you know, the old rule is for every 10 degrees Celsius you go above 25 degrees Celsius, you essentially have the life of your battery. Well, the AlphaCell FTX uses proprietary design to allow it to operate at continuous 35 C, so those elevated temperatures in warmer parts of the world where you know, you may not have HVAC or temperature control environments. And we have unique internal designs, in particular around the internal separator and the plastic materials that are designed to withstand the elevated operating temperatures and maintain the compression.
Okay, very interesting. You got a graph up here. Let's, can you explain that a little bit?
Yeah, sure. So what the graph is showing is it's demonstrating differences in separator material with impedance, right? So FTX has better performance over the FT at higher temperatures due to the fact it uses all glass pasting paper rather than a cellulose paste paper, which is what the FT uses and is a little more common. Using that glass paste paper, it minimizes and sustains better resistance than the cellulose, which allows it to sustain a longer float life at a higher temperature.
Okay. All right. Perfect sense. Thank you. So outside of this particular battery, what other evolutions are we seeing with energy storage for broadband inside plant?
So what's happening in particular in the broadband space is inside plant has traditionally been a temperature-controlled float service application, meaning that it's on backup constantly, waiting to be discharged in the event of a grid outage. So in particular, you know, you have 2 outages a year on average for a couple hours each time, right, in the continental U.S. But as the application shifts and there's more time of use, demand response things that come into play. In particular, I always use California as an example where due to the devastating wildfires and natural disasters that are occurring, you're seeing, you know, businesses and homeowners and people who use power in that state are required to disconnect from the grid for extended periods of time due to the grid being shut off. And when we say extended periods of time, we mean, you know, 72 to 96 hours. So very long duration. So you need a battery that is not only very energy dense and can run, but can also provide extended cycle life for, you know, a long period of time, right? And traditional lead acid products, you know, do have good energy density, but they're not as cycling robust as, say, another advanced chemistry is. We're continuing to make improvements to our heritage with TPPL by adding carbon to the battery, which allows for TPPL technology to cycle longer and have slightly longer energy density. But we're also advancing our efforts to have a lithium ion and a sodium ion solution as well too in the near future. More so lithium ion, but what the lithium ion product will do is give you longer runtime minutes, and longer cycle life. So you have that battery that can survive those sort of peak demand charges or the long duration outages that occur. We're also continuing to evolve the lead acid technology. There's a next generational shift called lead acid bipolar, which allows the battery to operate in a smaller footprint, a more modular, higher voltage footprint that gives longer runtime and higher energy density. So a lot of exciting stuff happening in the energy storage space today, just with the evolving, changing applications that happen in broadband. And EnerSys is well positioned to provide the necessary solution to solve the application needs.
Wow, definitely sounds like it. Thank you.
Mm-hmm.
Sounds like EnerSys is, as usual, is staying ahead of the curve, coming up with some really good innovations in the battery technologies. That's exciting news. Well, that's going to cover it today for our deep dive session on the new AlphaCell FTX series of batteries with thin plate pure lead plate grids for improved performance and service life in an XM3 system. Thank you guys both for joining. I want to thank Eric Hill and Grant for taking the time to be here and sharing their knowledge.
Thanks for having us, Greg.
Thanks for having us.
Anytime. Great. Thank you. And for those of you out there that downloaded to watch the video, I want to thank you and please come back for more. If you want to learn more about this, you can visit our website at www.alpha.com/broadband and look for the link at the top for email updates. You can also follow us on LinkedIn. Stay tuned and you'll start seeing more of these series of video discussions, deep dives, and technology updates. And look forward to seeing you soon. Thank you.